In today's lesson, we'll be learning about the operations with radical expressions. Before we were simplifying them, now we're going to complete operations, which just means add, subtract, multiply, and divide. And actually, specifically with today's lesson, we're going to be combining like terms, and then we will also be using the distributive property, but with radicals. Okay, the first three examples involve combining like terms. When you're dealing with radicals, it's similar to if you're dealing with variables. Let's say you have x and then you are adding 5x. You're simply just figuring out how many x's do you have. That would be 6x. It's the same idea with square roots. So here's the first example. If we have the square root of 2 plus 3 square roots of 2, all we're really asking is how many square roots of 2 do we have? We have 1 plus 3, which means we have 4 square roots of 2. So we're not actually adding these 2's together or anything like that. We're just counting how many square roots of 2 do we have. And we have 4. Next example. If we have negative 3 square roots of 5 minus 4 square roots of 5, we're just trying to figure out how many square roots of 5 do we have. So all you're really doing is you're worrying about the coefficients, negative 3 minus 4. So you have negative 7 square roots of 5. Okay, last example with just combining simple like terms. Square root of 10 minus 5 square roots of 10. How many square roots of 10 do you have? Really, you're just doing 1 minus 5. So we are left with negative 4 square roots of 10. And then you're done. With our next set of examples, what it's going to look like is at first it's going to look like we do not have like radicals to combine, but once we simplify them, then we might actually have like radicals. So for example, 7 square roots of 3 minus square root 12. So on the surface, it does not look like we have any like radicals, so that we cannot combine anything. However, you have to check to see if everything is simplified. The square root of 12 is not simplified, so let's simplify it. 7 square root of 3 minus, let's break up 12 into 4 times 3. And then the square root of 4 is 2. So 7 square roots of 3 minus 2 square roots of 3. So now, how many square roots of 3 do we have? 7 minus 2, we have 5 square roots of 3. So they might not look like terms at the beginning, but check to see if it simplifies any further, because then you might actually have like terms to combine. Okay, second example, 3 square root of 20 plus 2 square root of 5. It doesn't look like we have like terms, however, 20 is not simplified. So, let's see, 3 times the square root of, let's break 20 up into 4 times 5, plus 2 square root of 5. And then, the square root of 4 is 2. Bring the 2 out in front and multiply it by the front number. So 2 times 3, that is 6 square root of 5, plus 2 square roots of 5 equals 8 square roots of 5. Okay, last example with this category. 3 square root 3 minus 2 square root of 27. We can simplify that square root of 27, so 3 square roots of 3 minus 2, we can break it up into 9 times 3. Take the square root of 9, which is 3, and multiply it by the 2. So I have 3 square root of 3 minus 2 times 3 is 6 square roots of 3. So how many square roots of 3 are left over? 3 minus 6 is negative 3 square roots of 3. There you go. And the last part of this lesson is we are going to use the distributive property with radicals. So the square root of 3 times the binomial the square root of 6 plus 7. So we just simply have to distribute the square root of 6 times the square root of 3. Now, because they're both square roots, we can actually multiply 3 times 6 to get the square root of 18. And then now, when we multiply the square root of 3 times 7, since this number is underneath the square root and 7 is not, we can't actually multiply 3 times 7. We just have to simply write it as 7 square root 3. And then you have to make sure every radical is fully simplified. So 18, how can we break that apart? We can do 9 times 2 plus 7 square root of 3. And then this becomes 3 square root 2 plus 7 square root 3. And then you check to see if you have like terms that you combine. And we do not. So right here is our final answer. Okay, second example, the square root of 5a times the square root of 5a plus 3. Alright, so now when we distribute the square root of 5a times the square root of 5a, if you remember, anytime you multiply a radical by itself, it just cancels out the square root. And so this would just leave you with 5a. And the reason is 5a times 5a, that would be the square root of 25a squared, which this would simplify to 5, this would simplify to a. So when we distribute, this is just 5a. And then we distribute here, 5a times 3. You can't actually do 3 times 5 because 5 is underneath the square root and 3 is not. So plus 3 square root of 5a, and there's nothing else to simplify, so that is our final answer. Okay, last example, the square root of 2x times the square root of 6x minus 11. So when we distribute, here we have two numbers both underneath the square root, so we can actually multiply them together to get the square root of 12x squared. And then the square root of 2x times negative 11. Since 11 is not underneath the square root, all we can do is just minus 11 square root of 2x. Okay, now we have to make sure that everything is simplified. The 12 can break up, but the x squared is already a perfect square. So we can break this up into 4 times 3 times x squared, and we still have minus 11 times the square root of 2x. And now let's square root our perfect squares. The square root of 4 is 2. The square root of x squared is x, which leaves us with the square root of 3 minus 11, the square root of 2x. And that is all that we can simplify. That is it for today's lesson, so good luck.